Another day at the office for researchers at Snow Lab 2 kilometers down. This subterranean labyrinth still produces nickel, and the signs of a working mine are everywhere. At the end of a long dark tunnel, another world altogether, a stringently clean place of high science and experiments that probe the swirling edges of the cosmos.
So this is the halo detector. It's a supernova detector.
Down one corridor, a device made of lead and radioactive helium detects particles called neutrinos, given off by supernovas, exploding stars. The tiniest, most numerous particles in physics, neutrinos are the building blocks of the known universe.
All of the heavy elements that formed the Earth and the planets, etc., came from a supernova at some point in the past, were dispersed in space and available for the formation of planets.
It blocks neutrons, which are bad for dark matter experiments.
Elsewhere, they look for dark matter, which has never been seen or physically measured. This is science at its purest, precision engineering, rare materials, years of data collection. Much of it won't find anything, but should point the way for others who search.
When we look for dark matter, we're looking for the thing that we know how to look for, and that's the same as the analogy of a guy who lost his keys in the dark, and the only place he's looking is under the street lamp because it's the only place he can look.
Just what the discovery of dark matter means on a practical level is far from certain, but physicists insist it should point the way to a more fundamental understanding of the origins of everything around us.
If we understand dark matter, we can then understand things like how the galaxies form, how the universe itself has evolved from the Big Bang and moving forward through time. And so understanding dark matter will allow us to understand not only the particle that we think the dark matter is made up from, but even things like why are the galaxies here today.
It's not all physics. 2 years ago, a choir performed in one of the project chambers billed as the deepest concert ever. There are also plans to use the low radiation environment for medical research, seismic monitoring, and other uses.
The people who work in this unique lab know they're some time away from the discovery they seek, but they have no doubt at all about their mission, making sense of the universe from deep beneath the surface of a tiny fragment of it. Daniel Lack, Al Jazeera, Sudbury.